Good morning, my dear student. Here I am Dr. Viswajit Kayan, your chemistry teacher, assistant professor, Department of Chemistry of your college, Dr. Sudhit Chandrasoor degree. Sorry, it is changed. So, Dr. Sudhit Chandrasoor Institute of Technology and Sports Complex. Student, today we will discuss about the different type of organic chemistry. Here, different type of the organic chemistry means different type of the organic reaction, different type of the organic mode of reaction. Here, from this picture, you are clear that here the OH minus is attached to the carbon atom, and from this arrow it is very clear that the iodine or the iodide ion will be eliminated. So if you think about the cricket match, so when one of the player is injured, then another person from their team will replace by him or her. So this is called substituted fielder or something. So if in that case it is called substituted, so here this also substitution, because in place of the iodine there will be they take that position is taken by OH. So this is substitution reaction. Now here in this reaction, if you look here that the hydrogen and bromide both two are eliminated from this species. So it is basically an elimination reaction. And here if you look here, that is a one kind of addition reaction. That is, there is a yes some loss of each another thing, but ultimately it is a addition reaction. So yes, obviously we'll discuss in details in the next few slides. So hope you have already go through the topic or the term, that is inductive effect, resonance, etc. Nucleophilicity, that is nucleophile, electrophile, and its efficiency, basically nucleophilicity and electrophilicity. So now it will help you to understand the present topic. So if you categorize or divide the chemical reaction, or in case of the terms of the organic reaction, there will be these 4 type of the main organic reaction. Though again I am saying there is a organic chemistry, so it is a huge thing and its spanning is very high. So lots of type of the chemical reaction will be possible, but initially yes, these are the very basic and preliminary organic reaction. The first one is the substitution reaction, second one is the addition reaction, third one is the condensation or elimination reaction. So basically condensation reaction and elimination reaction are two types. That means I want to say condensation reaction is a particular type and elimination reaction is another particular type. Now hydrolysis, then oxidation and reduction, yes, by some oxidizing and reducing agent, then combustion. You are very familiar with this combustion because every day we are that is when we are coming by bus or something, due to the combustion of the fuel, that is the petrol or diesel, it will generate some energy, and that by using that energy will come to the college and we can go everywhere. So another is the acid base reaction, and this is a very simple. So first we will discuss about the substitution reaction. So I have already told you by giving an example of cricket field that the substitution reaction is um, or it is occurs whenever one atom of an organic molecule is replaced by another atom. So this type of the reaction will be often, or sometime it is required some reagent and some catalyst to make it faster. And here if you look here, sorry, there will be some mistake due to the different format of the word. So here you know that this is the methane. So the carbon has a 4 valency and each valency is fulfilled by hydrogen. And then if you add chlorine in presence of the sunlight, one of the hydrogen will be replaced. So here if you look here, this hydrogen is removed, and in place of this hydrogen there will be a replacement of the chlorine. So this is an example of substitution reaction, and very simple reaction. Now substitution reaction of benzene. So first one is the substitution reaction of alkane, or very simple type, but here the substitution reaction of benzene is very important, and the mechanism and other things are completely different from the previous one. So if you look here, the benzene ring, and benzene ring is exceptionally stable due to its aromatic character or aromaticity. So this molecule cannot try to lose its aromaticity. So, and another one thing, suppose there will be a nucleophilic attack, then, or electrophilic attack, but the ring is highly negatively charged, because if you look to the electron distribution in the benzene ring, you will see that in the upper layer there will be electron density due to the p orbital, and in the lower half there will be electron density due to the p orbital or the pi orbital. So in that case this reaction is not very simple like just before substitution reaction, but it is very specifically called aromatic substitution reaction. And the mechanism, if I get a time, I will discuss the details about this mechanism. So here the marked hydrogen is replaced by the bromine, and yes, again it is a substitution reaction, but again I am saying it is a completely different, the mechanism is completely different from the just we discussed above. So in case of the nitration, we use nitric acid, concentrated nitric acid and sulfuric acid as a mixture, then we will get a nitrobenzene. Here bond, the placing of the bond and other thing will be misplaced. So here through the carbon there will be a bond with the nitrogen. So yes, you are getting a term that is TNT, that is trinitrotoluene. So trinitrotoluene is an explosive. So yes, you can synthesize this explosive by this use of this reaction. You can synthesize this trinitrotoluene. But student, again I am saying it is not so much easy, but it is a very difficult job, and some people use it in the bad purpose, but yes, this type of the explosive has a high value to make different work, like making of road in hill area and lots of things, because you know that the explosive material is also required in our life for different purpose. Now, so new another thing, that is addition reaction. So in addition reaction, that means addition means I know it is very simply that addition means 1 plus 1 is equal to 2. So no loss. So 1 plus 1 is equal to 2. 2 plus 1 equal to 3. So there will be no loss ultimately. So if you go to the definition, that is in addition reaction, new atom or group are bonded to form an organic molecule. So basically, if you place something and if that thing is added to another thing, then obviously it is addition reaction. So this type of the reaction is mainly happen in unsaturated compound. Unsaturated compound means there will be presence of double bond or triple bond. So here this is your ethylene molecule, whereas the double bond is present, and here the heterolytic cleavage takes place. If you here this is actually one electron, that is radical, which is misplaced, and it will be in this carbon atom, like the another one radical is present. So there will be a breaking of the double bond and a single bond will be present, and in the two carbon atom there will be a two electron. So this is basically what type of the cleavage? Yes, this is homolytic cleavage. So now if you add hydrogen, then H pair, then it will be add to this system. So if you think about the hydrogen, then the two hydrogen will be add to the two carbon atom, and so from the left hand side it is the unsaturated, now it is saturated compound. So this is called addition reaction. So here HCl, so here H is added to the left hand carbon and Cl is added to the right hand carbon. So again it is the addition reaction. So here is the addition of the water, so that the picture is somewhat deviated. So here this is actually when the water is added, then this is obviously hydrolysis. Now this though it is not related to the reaction type, but yes, this is an example of the addition reaction, and this is used for the detection of the unsaturation of the compound. So if you add bromine, that is bromine water and other thing, then there will be a change of the color will be faded out. So if the color will be faded out, then we can say that the presence of the double bond, because here bromine is the brown color, or you can say it is red or brown. Then if it is added to the double bond, then the number of the bromine will be decreases, or if it is totally consumed, then there will be no bromine, so no question of color. So ultimately you will get this compound, and you can say there will be presence of the double bond. So by if it is not changes, then we can say it is a saturated compound, and if the color is disappeared, then we'll say it is unsaturated compound. So in addition reaction, there's the rules, that is Markovnikov rules. Markovnikov is a basically he is a scientist, he was a scientist. So here it rules told us that the orientation, or that is the addition of the heteronuclear molecule to the double bond, that is non-symmetrical alkene, will be defined. So here this rule tells us that if it is the unsymmetrical alkene, and if you add HCl or H pair, then the negative part of the reagent, or basically acid, if you add HCl, then Cl will be take position in the double bond where the number of the hydrogen is least. So again, please note it. Markovnikov rule tells us that the negative part of your reagent will be take position in the asymmetric alkene where the number of the hydrogen will be less, and the hydrogen will be take part where the number of the hydrogen present in the compound is high, that is with respect to the double bond. So here the statement, the more electronegative atom will be predominantly bound to the carbon atom of the double bond that has fewer hydrogen atom. So if you look here, so here is the unsymmetrical alkene. So if you number 1 2 3, so carbon number 1 has 2 hydrogen, but carbon number 2 has 1 hydrogen. So here the OH, when the H2 is dissociated, it's H plus and OH minus. So OH minus will be take part into carbon number 2. So student, here the negative part of the reagent, here it is H2O, that is OH minus, take position in the carbon number 2 instead of carbon number 1. But yes, there is a possibility of take position of the carbon number 1, that is OH may also take position in the carbon number 1. Yes, both two products are formed, that is 2-hydroxypropane or 1-hydroxypropane, or basically it is propanol. So two things are possible, but this 2-propanol is the major product compared to the 1-propanol. So 1-propanol is the the 1-propanol is the minor product and 2-propanol will be major product. So here again this is the same thing, that is most favored position for the hydrogen atom. Now this is your elimination reaction. Here the reaction is basically deformatted in my mobile phone. So here this is basically a condensation reaction. If you look here the 2OH part, so from one molecule 1OH and from another molecule AH will be eliminated, and these two are condensed and ultimately it form a ether molecule. So here from this molecule H2 is eliminated. So here is the again same thing. So yes, we'll here this is the condensation reaction. Here a alcohol, that is OH minus, and this is the part of acid. So when an acid and alcohol come to each other and react to each other, then the water molecule will be eliminated and a ester group, that is COO, is formed, and by this way we can make ester. So yes, we are not describing about the elimination reaction, so but we are describing about the condensation reaction. Condensation reaction is very important in terms of the formation of the ester, and you know that for the different purpose ester are very sweet in smell and they are used in the different purpose, like methyl butanone and used for the its fragrance is like apple. Now octyl acetate is its odor is orange. So those lozenges and other thing like cake and other thing So if you add octyl acetate, then it will be feel like orange smell. Now this all are the thing. So banana is the phenyl acetate. So elimination reaction here, if you look into the picture here, in this molecule there will be two bond, one is the hydrogen and the next carbon is the OH. So yes, if you add sulfuric acid, there is possibility of the removal of the water, and if the water is removed, then there will be a formation of the double bond in this position. So yes, it is perfectly example of the elimination reaction. In the previous case, yes, water is eliminated, but from the two molecule, but here from a one molecule the H and OH is eliminated, and this is perfectly termed as elimination reaction. So student, today I am not going to discuss about the oxidation reaction. In the next class we will discuss about the oxidation reaction and other thing. So mainly you have to read the oxidation reaction, elimination reaction, addition reaction and substitution reaction. And substitution reaction specially for aromatic compound, and we'll discuss elaborately. That is, substitution reaction are of SN1, SN2 type, again SN1 dash, SN2 dash and SNI type, that is internal substitution reaction. So yes, obviously we will go through that. So up to this, yes, again thank you very much student for your kind attention, and read it very carefully, and if you face any problem, obviously I am with you. Thank you very much.